Everybody for coming to the session today. My name is Chris Munns, and I guess we'll get started here. So quick show of hands, who here is already an AWS customer? Okay, who here is thinking about becoming an AWS customer? Okay, awesome. So that's who you are. Who I am is, again, Chris Munns. I'm a solutions architect for Amazon Web Services based in our New York City office. I actually come from the startup space myself, worked at a number of fun startups in New York City. And what I do is I work with our customers in helping them build, scale, be secure, and overcome all sorts of technical challenges on AWS. So actually I should ask this too, is there anyone who here is not familiar with what AWS is? This is a new concept to them. Nope? Okay, cool. So I can go through this pretty quick then. Essentially, AWS, we like to say that we are building blocks for infrastructure. And much like these colored blocks here that you probably played with as a child, you can put them together however you see fit to build and run your application and your infrastructure. And the way that it really kind of looks, oops, why is this not working? Is that we are a collection of a little over 30 services that, again, are for infrastructure. So everything from networking, compute, storage, and database on up higher through the stack. So some basics about AWS. We have a concept called regions. Currently today, there are 9 of these around the world. One is our GovCloud region for US government customers. The other 8 you could use completely interchangeably. We also did announce at the end of 2013 in December that we are opening up a region in China soon for companies that are based in China. Inside of these regions, we have a concept called availability zones. So availability zones are different plots of land that are inside of a region. They are 5 to 15 miles apart, different power grids, different flooded plains, different tier 1 ISP internet connections into them. The idea being, and we'll talk about this a little bit further, is that when you're building on AWS, we encourage you to build across multiple availability zones inside of a single region. So it's one of the key tenets when you're building on AWS is to follow this multi-AZ approach. Going along with this, we also have a number of edge locations for our CDN and our DNS service. There are over 50 of these today, and we're continuing to expand these. So again, looking at what AWS is, this is how you would see our services represented in our web console. Again, there's about 29 or 30 or so actual services here that you see, and then some of these contain some of the other services inside of them. But typically, this is what you're interfacing with. And so we're not going to go through all of these today, but just to get people to have an idea of the different services that do make up AWS. So the talk today, I really wanted to focus on key areas that startups should think about and should be paying attention to when they're building new applications and new infrastructure on top of AWS. So the first is security, then we'll talk a little bit about performance, and then fault tolerance and scale, and then lastly, cost. So diving in with security, and actually it's wonderful going on after the presentation from the folks at Wicker talking about security. We say that security is our #1 priority at AWS in running our infrastructure and helping our customers. So there's a lot that we could talk about. We're not going to touch on encryption. I think that's a given these days. But there are some things that you can do to be better about making your AWS account more secure. So the first one is multi-factor. So we give you the ability to make your credentials and your access to AWS via our web console and via some of our APIs accessible via a multi-factor. So this is either a physical token, like in the picture there, or via Google Authenticator or an Android app that we have. This is a really, really important thing. I don't know how it's like right now in San Francisco, but we've had an issue in New York City lately with people going out to bars after work and getting their laptop bags stolen. And those stolen laptops very often have passwords to things stored on them, such as your access to things like AWS. And the concern that we have is that you might potentially have your laptop stolen, your laptop hacked into, something along those lines, where you have your password stored in your browser, because everyone stores their passwords on their browser these days. And at that point, whoever it is that has stolen this could potentially have access to everything in your infrastructure. So having a separate form of authentication via multi-factor authentication is a great way to help protect against this. I'm a huge fan of the physical token myself. I keep it on my keyring, stays in my pocket all day long, and when I need to access the web console or some of the other tools, I'm able to pull it out and put in the code. So something that you really should be doing from day one with your AWS account. Again, you can use the free Google Authenticator app, or you could buy the tokens actually off of Amazon.com for about $13. But it's a really important thing. We're trying to work very closely with all of our customers this year to get them to use multi-factor authentication. The next thing we're talking about, I have a question here. How many people here are writing mobile apps that might tie into AWS, whether you're uploading photos or images or something? Okay. So we have a part of our service called IAM, Identity Access and Management. There's a subpart of that called Simple Token Service. Essentially what Simple Token Service does is it gives you the ability to generate unique access credentials to AWS services at time of use for your application. So historically, there have been some companies that have built apps on AWS and they've hard-coded credentials into their apps. It's actually very easy these days to reverse those credentials and then use them. So we did have a customer that was doing video uploads. Their application got reversed. They had static credentials in it. The credentials were posted on Reddit, and people basically could have abused their S3 account for their own use with these credentials. So all of our SDKs support Simple Token Service. It's a really key important thing to do if you are building a mobile application that you're allowing users to interact with AWS directly from the mobile device. And essentially what happens is you make a request to the service via your application to generate these credentials. The credentials are then fed back, and then you can use them inside the application when talking to AWS. These can be timed credentials. You can have them expire very quickly. You can have them expire over time. But the idea here is that you're not assigning unique credentials to every user with AWS. You're doing your own authentication, your own authorization, and then for AWS making use of this service. So there's a lot more in the documentation. I'm definitely happy to talk to people a little bit more about that later today. And then going along with this again, we have the service Identity Access and Management. I won't ask for a show of hands on this one, but a lot of people in startups have the habit of sharing credentials to AWS among everyone in the company. This is a really bad idea. It's something we strongly discourage. With IAM, you can create individual users for everyone inside the company. You can then force them to use multi-factor also, and you can give them really controlled policies to what they have access to. So let's say that you've got a development team separate from a, say, product operations team. You can actually now separate out who has access to prod, who has access to dev, differences between database admins, system admins, network admins, different service admins, et cetera. This is a really important thing to do also. People change companies, people get disgruntled, stuff happens, and you really don't want to be in a position where you have one shared credential for everyone in your organization, they move on, and then all of a sudden you could end up having a bad experience. So we really encourage people to look at IAM. It's something you should definitely be doing today as the default. The next thing, and this is something that's been part of AWS from day one, is around security groups. So security groups are essentially firewalls that are built into anything that's based on top of EC2. So EC2, Relational Database Service, Elasticache, EMR. But we find a lot of people don't do a good job of tightening up their security groups. So again, this is something that's very important to do. It provides this firewall below the host level. One of the great things that you can actually do with security groups is you can tie them directly to each other. So instead of having to open up to an IP address or a range of IP addresses, you can allow security groups to be tied one to another. So you can say that the web tier can talk to the application tier, but it can't talk to the database tier, and vice versa. You could allow it such that you have a essential bastion host that you're logging in through, instead of having every host that you have in your infrastructure open to the internet for SSH. So another really important thing to kind of reduce the visibility that you have out on the internet to your services, kind of reduce that security fence that you have available to the outside world, and really tightening things up through security groups is an important way to do that. So next up, we're going to move on to performance. Performance is another thing that we could spend the entire day talking about. It's a really deep category. One of the biggest things that I find that startups don't do really well is choosing a proper instance type for their workload. We have over 25 different instance types now. We just added a few more in the last couple of months. A mix of instances that have higher CPU, that have SSD, that have more memory. So there's a lot of different options out there for you. And a lot of people sometimes make the wrong choices in picking what instances to use. A lot of startups will tend to use really small instances because they're very cheap, but then they use a lot of them. And the problem there is that you're paying for this resource that is obviously not a super powerful resource as it being one of the smaller ones, and then sometimes you find that you're not getting the performance that you're looking for. So often there's the problem of people, again, going too horizontal when they need to go vertical in scaling. Sometimes we see the exact same thing. The inverse of this is that you shouldn't go out and use the largest, biggest, best instance just because. Often you may not need your application may not need an instance of that size. So really try to spend the time to fine-tune your application based on the resources that are available and make it fit based on your work case. Going along with the instance type is the amount of storage, or the type of storage that you might have attached to your instance. So there's a number of different storage options on AWS, and so you'll want to be aware of which ones you're going with. So there are two types of storage that are attached to EC2 instances. There's the local or ephemeral or instance-based storage. This is storage that lives on the same physical host as the virtual instance will be running on. And then there's EBS, Elastic Block Store. So EBS you could think of as essentially network attached storage that you provision based on the amount of size of the data that you want to have on it. So for the local ephemeral storage, there's both regular disks, and then there's also SSDs that are available depending on the instance type. And then for EBS, there's standard EBS, and there's also something called provisioned IOPS. When you're trying to decide between the two and what storage makes the right sense for you, there's a couple of different caveats that you need to take into mind. For the ephemeral storage or for the local storage, it's not persistent. So if your instance dies, you lose the data that was on that instance. So it's not necessarily the best place for super important data or super critical data to your application. You can also do things like RAID across the volumes that are available to you to give you better performance on that data. For EBS, it is persistent. So it's backed up and stored actually off of the hardware that the instance is running on. You have the ability to do things such as snapshots, which are a fantastic way to do backups and restore of your data. And again, because you get to tune the size and the performance with provisioned IOPS at least, it can give you a much better matching to what the workload is that you're running on top of AWS. So again, it's not always a one-size-fits-all. Most infrastructures are a mix of these two, and it really depends on part of the application and how you have it set up. And then lastly, also with EBS, using RAID across multiple EBS volumes does give you increased performance. So use cases, again, ephemeral data makes sense for your local application, your operating system, or databases that you're doing a really high level of replication, so things like Cassandra or MongoDB. But EBS makes a lot more sense if you have a relational database or for really important information for your application. So if you have people uploading data directly to AWS and not going to S3 but going to EBS, then it definitely makes sense to, going to EC2, then it definitely makes sense to do that directly to EBS. And the next part of this is that we have a service called S3, Simple Storage Service. This is actually probably the best place for most of your data. Anything that does not need to be in a database that you're actively querying should be in S3. S3 is what we like to call an infinitely scalable web object store. Great for static content, great for logs, great for backups, great for images, videos, anything that might be getting uploaded by your users. But a lot of people don't leverage S3 as deeply as they should. So something you should definitely spend more time looking at, especially when you're thinking about how data flows in and out of your application. Monitoring performance is then the next big piece that a lot of people don't do really, really well. This is a screenshot from OpsWorks, one of our management tools. OpsWorks gives you a lot of ability to view metrics about what's going on inside your application, how it's performing, how your infrastructure is performing. This is a screenshot then from CloudWatch. So CloudWatch is a service that we have that integrates with almost all the rest of our services. You can set up alerts, you can do some light trending, but another thing that people don't spend enough time looking at is the actual graphs and data that's behind the scenes for the services that they're using. So be aware of these things, get familiar with these tools. Again, CloudWatch being built into the platform means that you really don't have to pay for it as anything extra. It's already there and it's already part of what you might be using. The next biggest thing, and this is a huge thing that I find a lot of startups don't do a lot of, is making use of a CDN. So a content delivery network, we talked before about how we have these edge locations around the globe to serve out your content. Many, many startups don't take the time to put a CDN in front of their website. It can be really incredibly valuable for you, and it can help take off the edge from needing to increase the size of your infrastructure. It can also dramatically speed up the performance of your application. There's a graph in the bottom corner of this slide here of traffic across a website that was a customer of ours that used CloudFront. And so they had this massive traffic spike, you can see, where they had gone from under 20 gigabits per second to over 80 gigabits per second, and CloudFront just took care of it for them. They didn't have to do anything extra to handle that. So when it comes to caching your content at the edge close to users, again, this is a very important thing that a lot of startups aren't doing, but that I try to encourage every startup that I work with to take advantage of. Next up, we're talking about fault tolerance and scale. So I'd like to ask what the difference is between these two pictures. So we've got the Leaning Tower of Pisa on one side, we've got the Eiffel Tower on the other side, and you'll notice that one is a lot more crooked than the other is. So why is that? Much like your application on AWS, the Eiffel Tower is built on multiple individual piers, essentially, that are holding it up. So when you're building your application, you don't want to be inside of a single availability zone. You do want to make sure that you're doing multi-AZ, so that you are taking advantage of failover and scale that's available to you. Another thing when we talk about your infrastructure is I have this concept of pets versus cattle. A lot of people, when they're building out infrastructure and they're doing it for the first time, spend a lot of time hand building their servers, spend a lot of time caring about their servers, and so they treat them much like pets. We have this philosophy at AWS that you really should be treating your infrastructure like cattle. So what I mean by that is don't get so attached to your infrastructure. One of the core concepts of AWS is that you should be building to be fault tolerant. You should be building to handle failure that is almost positively going to happen. It's just part of daily life. People, when they have physical infrastructure, spend a lot of time and a lot of money making all of their physical infrastructure super resilient to fault. Having multiple power supplies, multiple network connections, multiple disks. This is actually a really bad anti-pattern. And in the cloud, you don't need to do that. So we encourage people to try to get rid of any sort of golden egg pieces of infrastructure, things that are so important, and if they ever died, the entire site would go down. Try to leverage services that have fault tolerance built into them. Try to always make sure that you have 2 or more of any sort of component inside your infrastructure, and make sure again that you're automating all of this work so that you're not doing this manually every time. Another service that we talk about, and when we talk about people that are doing capacity planning, a lot of websites have a traffic graph that looks a lot like this. So you've got peaks, you've got valleys, and a lot of times when people are doing capacity planning, they'll kind of draw a line above what they think their peak traffic is, and then say, okay, well, this is what we're going to game our, or aim for the amount of resources that we have running and make available for our application. So you might run you might be running 8 web servers because you say, well, I only probably need 6, but I'll have some overhead. And so this can work out really well, and this is what your traffic pattern looks like. But as soon as your traffic pattern looks like this, putting that bar up above some percentage of your potential traffic becomes a lot more difficult. You get a lot more waste in here, a lot lower utilization. So at AWS, we have a service called auto-scaling that you can use to help essentially match your capacity to the traffic that you have coming in. So auto-scaling is a really great service. It's part of EC2. You don't have to pay anything extra for it. But what it can do is essentially horizontally scale out a single tier in your application based on load, based on traffic, based on the performance metrics. So this is a really great thing that you can use to help control cost and again, make your web application more performant. Going along with this is a service we have called Elastic Load Balancer. It's a really important service that you can use to put in front of tiers like auto-scaling. It will scale up for you, offers resiliency, does health checks, and many of our largest customers are using ELB in a big way. So I'm sorry, we're running a little over time here. I'll try to rush through the rest of these slides. So the last section here is cost. So cost is a very important thing to all startups. If you're able to raise some money or you're bootstrapping yourself, cost is one of the foremost concerns that you do have. On AWS, there's a lot of different knobs that you can turn, a lot of different levers that are out there when it comes to cost. And you really should spend the time to understand our cost models. So here I have a number of our services that actually do have different cost models. Those that are built on top of EC2, so EC2, EMR, Elasticache, Redshift, and RDS, all have a number of different cost models. They all support on-demand. They also support reserved instances. But then with EC2 and EMR, we can also do spot. So can't go into all that today, but again, there's lots of different ways that you can pay for your infrastructure on AWS and that you can run your infrastructure in AWS. And you really want to spend the time to make sure that you're doing the right thing when it comes from cost. As part of that, we have some tools to help you out with that. So we have a new billing console that we launched back in January here. So you can go through the web console to /billing. You can also find it by clicking on your name when you're in the console. And so this is going to give you information about what your current spend is at any point in time, show you the breakdown of it across different services, show you what you spent last month, and give you access to different reporting. There's also a really great tool that I'm encouraging a lot of my customers to use called ICE. Came out of Netflix. It's one of their open source tools that they put out there. Essentially, ICE makes use of our billing reports and gives you all sorts of really deep information about what you're running on AWS and what that might be costing you. Lastly, this is another one that we really are encouraging our customers to do. We have billing alerts now. Essentially, what you can do is go and set an alert based on where you think your billing should be. So if you're trying to control your expenses, you want to see how that's working out over a certain time period, you can go through through CloudWatch or through the billing console, set up these alerts. Another thing that startups don't do really well is turning off things that they're not using. So when I go and work with a startup and they say, we're concerned about what we're spending, I'll go through them and I'll review everything that they have running. And more often than not, there's the story of, oh, well, there was a developer that turned something up in this one region, and then they left, and none of us paid attention to the fact that it was running, and they'd be getting billed for it for the last couple of months. So really spend the time to go through your infrastructure to see what you have running, to see what you don't use, what you don't need. Another thing this really makes sense of is if you are doing dev and test on AWS, turn that stuff off after hours. Things that are backed by EBS you can put into a stopped state, so you don't have to rebuild it or re-provision it in the morning. And so there are a lot of different tools and a lot of different open source scripts you could find to help you with that. Use things like auto-scaling again to help shrink down tiers during lows in your traffic so that you don't have all this extra capacity running all the time. And again, use smaller resources when necessary. Don't go with the idea that, well, I have to have the most powerful host because maybe that's what I did in a physical data center, or that's what I'm comparing it against. Use an instance that's the right size for you. So the last thing that I have to talk about today is Trusted Advisor. This is part of our business support offering that we have. So it starts at $100 a month. Trusted Advisor is a really great tool that we have for helping you do and help review all the things that we talked about today. So essentially, Trusted Advisor is part of our platform. It runs in the background across a number of our services. There's over 32 different checks that we have today. And it provides you with guidance and recommendations on cost optimization, security tweaks that you should be making. So if your security groups are too open, fault tolerance. So again, not being a Leaning Tower of Pisa, but being an Eiffel Tower. And then lastly, just performance of your applications. So if you're underutilized or overutilized in some fashion, Trusted Advisor gives you that information. Business level support, again, has a lot of different benefits to it. Trusted Advisor, though, often will pay for itself the first time that you use it for the rest of a year. So really encourage people to sign up for business level support, again, just to get access for Trusted Advisor. So again, thank you guys all for your time today. We do have a booth down here in the main exhibit hall, and we'll be here for the rest of the day. You can come down and ask us any sorts of questions. Again, I can answer anything from a technical perspective or an account perspective, and we appreciate all you being customers. So thank you.
You might have individual questions you want to check out with Chris individually. I had one. If someone's starting from scratch, because you guys have so many incredible services, right? Mm-hmm. What's the front door like? What's the very first place, other than like having access to you today, which is amazing, and your whole presentation, which people can review? Like, what's kind of the main funnel entry point to figure out, okay, which category I am, and I'm a startup that's scaling really quickly, so I need to have some flexibility. Where do I begin, and what's kind of the trajectory?
Sure. So we have a service called Elastic Beanstalk. It's kind of a platform as a service that sits on top of a lot of AWS services. Essentially, you toss your code at it, and it builds a infrastructure out for you that does auto-scaling, that does healing, that provides a number of other metrics and reports. So you don't have to know how the AWS components work. You literally can just point it at a Git repo, and if you are writing your application in PHP, Ruby, Node.js, Python, .NET, or Java, it will just stand up again that infrastructure for you. So I encourage a lot of startups, a lot of people at hackathons to use Elastic Beanstalk as a place to get started. One of the things that differentiates it from a lot of other platform as a service products is that instead of hiding what's going on under the hood, with Elastic Beanstalk, you can actually get in under the hood, turn all the knobs, find out what's running, and then it kind of can help you learn more about AWS via using that service.
Questions? Questions? Okay, Chris is going to be here. He's an amazing resource. Please take advantage of him. Thank you so much for being here.
Thank you. Thank you, everybody.